Let's look at the binomial distribution. The NBA player with the highest career free throw percentage is Stephen Curry, who has made 91% of his free throws. If he shoots 10 free throws, what's the probability that he will make exactly 8 of them? Suppose we have an experiment like this, which has two mutually exclusive and exhaustive outcomes, like win and lose, success and failure, hit and miss. By the way, these experiments would be called Bernoulli trials. Let x be the number of successes we obtain in n independent trials, where p is the probability of success on one trial. Then x has what we call a binomial distribution with parameters n and p. So let x be the number of free throws that Stephen Curry makes out of 10 attempts. Then x has a binomial distribution with parameters n equals 10, that's the number of attempts, and p equals 0.91. That's the probability of success on one particular attempt. So if x has a binomial distribution with parameters n and p, n's the number of trials, p is the probability of success on each trial, and f of x, that's the probability that x takes on a particular value, is, okay, this symbol, this is what we say n choose x. It's going to be n choose x times p to the x times 1 minus p to the n minus x. This is where n choose x, it's n factorial divided by x factorial, n minus x factorial. What do we mean by n factorial? Well, n with the exclamation point looks like n, but it's not. It's n factorial. That's n times n minus 1 times n minus 2, blah, 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 times 3 times 2 times 1. In other words, it's the product of the first n integers. Some books use q instead of 1 minus p over here as the probability of failure. And sometimes we write n choose x as c of nx or ncx because it's also the number of combinations of n objects chosen x at a time. Wow, that's hairy. How are you ever going to remember all this? Oh, you'll be fine. So again, f of x, that's the probability that x takes on a particular value. It's n choose x times p to the x times 1 minus p to the n minus x. We want to know the probability that x equals 8. In other words, the probability that Stephen Curry makes 8 free throws, that is, in other words, f of 8. So that's going to be n choose x, that's going to be 10 choose 8. N is the number of trials, which is 10. X is the number of successes, that's 8. Times p to the x, p, the probability of success on one trial is 0.91, x is 8, times 1 minus p, in other words, 1 minus 0.91, times, or raised to the n minus x, that's to the 10 minus 8. In other words, 2. Okay, so we have 10 choose 8 times 0.91 to the 8th times 0.09 to the 2. Okay, so here's how we evaluate 10 choose 8. So in general, n choose x is n factorial over x factorial, n minus x factorial. So 10 choose 8 is 10 factorial over 8 factorial, 2 factorial. 10 factorial, again, it's going to be the product 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 2 factorial is just 2 times 1. I don't know if I mentioned this, but 0 factorial is by definition 1. So it's not 0 as you'd expect. It's just 1. And that all comes out to be 45. Okay, that's 10 choose 8. There's an easier way to evaluate it. If you have a TI-83 or TI-84, to access the factorial button, you press Math. Here's the Math button. Okay. And then you choose PRB, just scroll over to PRB, and under that you can choose factorial. So 10 factorial, for example, would be this, 3,628,800. Yeah, it would be, so 10 factorial divided by 8 factorial, 2 factorial, this is how you'd enter it on your TI, and that would just give you 45. Okay, you can also do this if you have a TI Inspire. Here's how you'd access factorial. So you choose Calculate, and then Menu, just press the Menu button, and you choose under Menu, you choose Probability, and then under that choose Factorial. And so you could calculate 10 factorial in that way. So first you type in 10, then you type in factorial, and it would give you the answer. There's actually an easier way to calculate 10 choose 8 on the TI-83 or TI-84. You don't have to even bother with factorials. So you would press 10, in other words, you type in 10, And you press the math button, and again you choose PRB, and you would choose NCR. Okay, do that so you don't even have to bother with factorials. And then choose 8. So you should see 10 NCR 8 on the screen. You press enter, and it would give you the answer, 45. See, now isn't that easier than using factorials? So you could do the same thing on the TI Inspire. Again, you would choose calculate, and then menu, press the menu button, choose probability, and then choose combinations. So your calculator is going to spit out NCR, and then a couple of parentheses like that. And inside those parentheses, you would just type 10, 8. That would be the way we enter 10, choose 8. You press enter, and it gives you the answer of 45. So why does this formula work? Well, again, we're looking at the probability that Stephen Curry makes 8 out of 10 free throws. Here's the formula I've given you. Let me show you why it works. If you can follow this, great. If you can't follow it, it's probably okay. I don't know what your teacher thinks about it. I make students understand the formula in higher level courses. In lower level stats courses, I present it, but I don't insist that they really understand it. It would warm my heart if they did, but sometimes they just don't. Okay, so here's why this formula works. In this particular problem, the probability that Stephen Curry makes 8 out of 10 free throws is 10 choose 8 times 0.91 to the 8th times 1 minus 0.91 to the 10 minus 8. In other words, we end up with this. Okay, so here's why this formula works. This is the probability that he makes the first 8 free throws, hit, 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 and then miss, miss. So the probability that that happens is 0.91 to the 8th. So that's the probability that he makes the first 8 free throws times the probability that he misses the next 2. That's going to be 0.09 times 0.09. Works out to be this. The probability that he misses the first 2 is going to be 0.09 squared. And then this is the probability that he makes the next 8, 0.91 to the 8th. And again, it all works out to be the same number. So really, the order doesn't matter. The probability that he makes 8 free throws and then misses 2, regardless of the order, is going to turn out to be this. So now, we just need to calculate this. How many other possible arrangements of 8 hits and 2 misses are there? Well, you could do 8 hits and 2 misses. You could do 2 misses and 8 hits. The number of ways to arrange 8 H's in 10 empty slots, that's the number of combinations of 8 objects chosen from 10 distinct objects, and that's 10 choose 8. So that's where we get the 10 choose 8 from. So again, it's going to be 10 choose 8, that's the number of ways we can arrange 8 hits and 2 misses, times the probability of, the probability that he makes the first 8 free throws and then misses the next 2. So that's going to be 45 times this, which turns out to be 0.1714. In the English Premier League, players make 83% of penalty kicks. 13% are stopped by the goalkeeper and 4% miss the goal. Let X be the number of penalty kicks a player makes out of 4 attempts. This is not the English Premier League. This is just the Chicago Fire, our local team. Okay, so let's create a table for f of x. Again, x is the number of penalty kicks a player makes out of 4 attempts. And we're going to give answers accurate to 4 decimal places. And we're going to use the same formula we had earlier. So this is what we use to calculate the probability of a particular value of x when x has a binomial distribution. Here n is 4 trials, and the probability of success in a particular trial is 0.83. So first let's calculate f of 0, the probability that the player misses all 4. So that would be n choose x, in other words 4 choose 0, times p to the x, that's 0.83 to the 0, times 1 minus p to the n minus x. That's 1 minus 0.83 to the n, which is 4 minus x, which is 0. Okay, on your calculator, you find that 4 choose 0 is 1. 0.83 to the 0, that's just going to be 1. And then 1 minus 0.83 to the 4. All of that turns out to be 0.0008. Okay, here's an even easier way to find this. Oh man, now you're going to be set. So all of this stuff that I just did on the previous page, you can just do this on your TI. So in your TI-83 or 84, you press distir. Distir's here, so in order to get that, you got to press second and then vars. And then under distir, which stands for distributions, you choose binomial PDF. Not binomial CDF, but binomial PDF. Okay, so we want it. Well, your calculator will spit out binomial PDF. And then we enter n comma p comma x. N is the number of trials. P is the probability that probability of success in a particular trial. X is the number of successes. So this is going to tell us the probability that out of n trials, we get exactly x successes. In other words, it's going to tell us f of x. So your calculator is going to have binomial PDF. You would just type in 4, 0.83, 0. That's n, p, x. Press enter, and it will spit out this number. Oh my goodness, what is 8.3521e negative 4? That's calculator notation for scientific notation. 8.3521 times 10 to the negative 4th. In other words, it's going to be 0.0008351. That's our answer. Okay, so you can also do it if you have a TI Inspire. You would just, again, choose Calculate, and then press the menu button, choose Probability, and then choose Distributions, and then under Distributions, choose Binomial PDF. And you'll come up with this screen. So the number of trials is n equals 4. Probability of success in a particular trial is 0.83. And then your x value, that's what we're trying to find. The probability of x successes, probability of 0 successes, that's going to be 1. And then you press OK. Really, you're not pressing buttons on this. You're just using your down arrow to go from spot to spot. And once you get to OK, then you can press enter. And your calculator will spit out the same number, which is 0.0008351. You can also use Excel to do this. I would recommend binomial distribution range. And the variables you enter in there are n, p, x. So you would just type in equals, you'd open Excel, and then you type equals binom, and Excel is smart. It gives you some options. Hey, is this what you want? And you say, yeah, that's what I want. So you press tab, and it will spit out this. So that's what's going to be in that first cell. And again, you want n, p, x. N is the number of trials, that's 4. P, that's the probability of success in a particular trial, which is 0.83. And then S, well, that's x, really. So that's the number of successes. So you enter those, and you'll come up with the same answer, 0.0008. So if you do that for all of these, if you change x, in other words, from 0 to 1 to 2 to 3 to 4, you'll end up with this. So the probability of 1 successful penalty kick is that. Probability of 2 successful penalty kicks is this. Penalty of 3 successful penalty kicks is this. And notice that the players most likely make all 4 kicks successfully. That probability is 0.4746. Okay, graph f of x. You can do this by hand or use Excel. This is what f of x would look like. Is this graph skewed left, skewed right, symmetrical, or none of these? Well, if a graph is skewed left, that means this tail is to the left. If it's skewed right, the tail's to the right. If the graph is symmetrical, of course, it's going to look something like this. It's going to be symmetric. And if it's none of these, it's not going to be symmetric. It's not going to be skewed right, skewed left. You'll end up with something that looks like this. Okay, our graph is skewed left, so the tail goes to the left. Another example, suppose the probability of rolling a 7 on a 7-sided die is 0.13775. I know that's the answer based on 20,000 rolls. I actually rolled that die 20,000 times, believe it or not. We roll a 7-sided die 100 times. Find the probability that we get exactly 14 sevens. So if you do this on a TID3 or TID4, in this case, n is 100, number of trials. Probability of success on a particular trial is 0.13775. We want to know the probability that we get exactly 14 successes. So we enter that on a TI-83 or 84. On a TI Inspire, you would just choose binomial PDF. In this case, n is 100, p is 0.13775, x equals 14. And any way you slice it, you get this as the answer. How about the probability that you get less than or equal to 10 sevens? Okay, for this one, we want binomial CDF, not PDF like in the previous problem, but CDF. That's cumulative distribution function. So binomial CDF n, p, x tells us the probability that their variable x is less than or equal to little x. So in this case, n is 100, number of trials. Probability of success in a particular trial is that. And we want to know the probability that we get less than or equal to 10 successes, so X in this case would be 10. On the TI Inspire, a little different. So N is 100, P is 0.13775, and then the lower bound and upper bound, okay, for that one, the lower bound is 0, upper bound is 10. You just enter that, and it's going to give you the right answer. So at least 12 sevens. Oh, these at least at most problems, they're a bear. Here's how we calculate that. So when you see the problem, at least 12 sevens, just think to yourself, okay, what does that mean? It means it could be 12 or 13 or 14. I would encourage you to literally do this, that you don't screw it up. Now the TI-83 or 84, unfortunately, doesn't have a button like this. It just has cumulative distribution function. So the easiest way to calculate the probability that X is greater than or equal to 12 is 1 minus the probability that X is less than or equal to 11. That's 1 minus f of 11 plus f of 10, etc. That is, in other words, 1 minus binomial CDF, 100, comma, 0.13775, comma, 11. And that turns out to be 0.7388. You can also do this on Excel. So again, binomial distribution range. So n comma p comma, okay, in this one, it's from x to y. So in this case, you'd have x equals 12 and y equals 100. You enter that, and it's going to give you the right answer. Okay, find the mean, variance, and standard deviation of x. So if x has a binomial distribution with the parameters n and p, then the mean mu of x is np. The variance sigma squared of x is np times 1 minus p, and the standard deviation sigma, it's just going to be the square root of the variance. That's just the square root of np 1 minus p. So the mean is going to be np, that's 100, times 0.13775. That's 13.775. Makes sense. If this is the probability of success on one trial, then how many times would you expect to be successful in 100 trials? You just multiply that by 100. The variance is going to be np 1 minus p, so it's 100 times 0.13775 times 1 minus 0.13775, that's 0.86225. That turns out to be 11.8775. The standard deviation is the square root of that, namely 3.4464. By the way, LeBron James, one of the greatest players in NBA history, the leading scorer of all time, and Stephen Curry, one of the leading, possibly the best shooter of all time, were both born in Akron, Ohio. Fun fact.